Okay then, well, let's get started. My name is Marshall Clow, and this is the last talk of the first day, titled, You've Written a Library, Now What? And in this talk, I'll be using library as a shorthand for some piece of software. It doesn't have to be a library, it could be application, and I'm going to couch it in terms of, you're doing an open source thing, but it's not a requirement because most of the things I'm going to talk about apply to non-open source projects as well. There will be very little code here. I'll talk about code a lot, but mostly this talk is about things that go around the library. Support things, ways to make your library better, ways to attract users, ways to keep users, ways to help users use your library to further their ends, that kind of thing. I'm not going to talk about marketing and distribution and things like that, not because they're not important, they are important, but rather because I don't know very much about them. Okay. About me, because, well, it's always all about me. I've been working on LLVM, the open source compiler framework, for about 9 years. I work on libc, which is the standard template library, the C++ standard library implementation for LLVM for about 7, and I'm the code owner, means I'm the responsible party for. It doesn't mean that I wrote the whole thing or that I am the person who writes all the code for it. That's not true. There are several people who contribute. It just means that I direct or coordinate as opposed to manage. I'm also the chairman of the library working group in the standards committee. Again, I coordinate a bunch of people's work. My day job is I work for the C++ Alliance, which is a US-based nonprofit organization. Their mission is to promote the development of open source C++ libraries. End of commercial. Various ways where you can contact me: email, Slack, IRC. During this talk, if you have any questions, please just put your hands up and we'll take care of them right away. On occasion, when somebody asks a question, I will say, hang on to that because I have a slide for that coming up, but in general, I will try to answer them just immediately. And let's begin. Start with documentation. Does your library have any documentation? GitHub, if you host it on GitHub, they really encourage you to write a README, but an amazing number of them don't. Everybody likes to slag on documentation, okay? Documentation is not simple, but neither is it really, really difficult. You want to have some documentation, some useful documentation for your library, because this is how people evaluate your library in many cases. They'll come and look at your library, and if they don't, they'll try to read the docs. And if there are no docs, or they're just terrible, they'll say, oh, well, the docs are terrible, the rest of the library is probably just as bad, and they'll just move on. This is how you make a first impression. I also do a lot of work with Boost, and one of the things that happens with a Boost review is there are people who don't even look at the code for a Boost review first. They'll spend 3 or 4 days reading the docs and understanding the problem that the library is supposed to solve, or the problem domain that the library is supposed to help with, and try to write sample code from the documentation, and then they'll start looking at the code. So you definitely want to have good documentation. You might say, I know what my library does. Well, yes, you do. I sure hope you do. You wrote it, right? But don't you get tired of explaining it to people? Wouldn't it be better if somebody asks you a question, you can just reply, say, here's a link to the docs, or here's a link to a section in the docs, which is even better. And it also helps, thank you, helps convince people that you've considered, you can say, here's a link to the documentation that answers your question. There's a thought there that, hey, he's thought about the problem that I was worried about. And that's a great thing. Okay. Yeah, you don't want people to dismiss your library out of hand just by looking at the documentation. That's a quick failure. Okay, so what kind of documentation should you have? An overview. What does your library do? Does it implement all the infrastructure to build a multiplayer blackjack game? Does it, is it a solitaire game? Is it, some financial trading system? What does it do? I don't know. You have a name that says Fritz Bar. That maybe doesn't tell anybody anything. You've chosen a clever name that means something to you, but does it mean anything to your potential users? Some kind of getting started documentation. Some way, to say, how do I get started with? How do I install it? How do I build my first program with it? What can I expect to do? Hello, basically the equivalent of hello world. Examples. Again, I'm assuming here that we have a library that you want people to write code to use. Examples. How do you use this? How do you use this to do whatever? A friend of mine, Howard Hinnant, has written an open source date library, basically calendar library. And it has a whole bunch of examples, and he's always on the lookout for good examples. So I asked him when he was working on his library, I said, hey, Howard, I have a friend who's a little bit older than I am, and Dave was born in Los Angeles at 2 o'clock in the afternoon on such and such a day. I said, Dave is getting up there in years. He's going to be, well, a couple years before this, he had turned 60. And I said, I know that 1 billion seconds is about 31 and a half years or so. I said, when will he be 2 billion seconds old? That would be a funny thing to know because I could throw him a party. It's a kind of a geeky party. And Howard sent me back a little 10-line snippet that basically said, run this program. And he basically set up a date, his birth date, and added 2 billion seconds to it and printed out the new date. And it turned out to be last year sometime. It turned out to be actually right around the solar eclipse that was up in Oregon. Was that last year or was that a year and a half ago? Now I don't remember. Anyway, the point was, and then he took that example and asked me if it was okay and shoved it into his documentation as this is how you calculate when somebody is 2 billion seconds old. As an amusing story about Howard's thoroughness, he sent me an email about 4 months later and said, oh, by the way, that program I sent you, it's wrong. It gives the wrong answer because there's been 37 leap seconds since Dave was born. And my library was not taking those into account. It's been fixed now. Anyway, examples. Tutorials, examples are for getting started or for doing individual things. Tutorials are more for building something more complicated, more complex. And reference documentation. What do the calls in your library do? There are tools for generating reference documentations from the source code. Doxygen is probably the most common of these. Okay, you put comments in your source code, and Doxygen will extract them and build web pages or PDFs or whatever. This is a fairly painless way of doing it. Interestingly enough, Clang, the compiler, has a mode in it called -f documentation where it will read the Doxygen comments and compare them to the prototypes of the function that it's supposedly documenting and will throw warnings if they don't match. So the nice thing about that is if you delete a parameter, say, from a function and forget to update the Doxygen comments that the documentation is generated from, you'll get a compile time warning saying, hey, I don't know, you talk about this parameter fooby in your Doxygen comment, and there is no fooby. So that's kind of cool. Okay, questions about documentation? Yes?
One remark regarding the point two, what I almost always miss in libraries
Okay, the comment is that what is frequently missing in getting started with libraries is how to integrate it into a build system. That's a good point. It's a very good point. I mean, if you have a header-only library, since we're going to talk about C++ a little bit, integrating it is almost nil. But if you have something you have to build, an object file or something, or some assorted data file, then yes, you have to integrate it into your build system. And unfortunately, we are not yet at the point where there's one true build system, and I don't think we'll ever get there. So yeah, having a list of dependencies and how you build it, not only just how you build it in isolation, but rather how you integrate it into the product that you're building would be a good thing. Thank you. Back there, then here.
Some TDD enthusiasts claim that you shouldn't write examples, tutorials, and reference, but just publish the tests for the library.
The comment was some TDD enthusiasts suggest you don't need examples and tutorials, but rather just publish the tests. It's a good point, and I have more slides about tests, but I don't think I agree. And the reason I don't think I agree is because tests and tutorials have two different goals. One of them is to produce confidence about correctness, and the other one is to inform or teach. And those are subtly different. There's a bunch of overlap there, but I think they're different different objectives. Because a tutorial, if I was writing a tutorial, the idea is that at the end of the tutorial, the person reading the tutorial understands why things are being done as well as how you do them. Okay.
You mentioned keeping the document up to date, and I checked that, and it feeds into the kind of TD. Should examples be executable and make sure they're up to date?
Absolutely. The comment was about the reference documentation, the compiler checking it. The comment was about the tutorials and the examples. They should be, you should be able to build them and execute them as part of your testing to make sure that they're still relevant. They still build, they still execute. And then you probably have to go back and look at them every now and then to make sure they're still relevant. They're still teaching the kind of things that you want. Okay. Next up, tests. Disclaimer, I really, really like tests. Okay? A good set of test suite, a good set of tests, a good test suite, whichever you want to say it, keeps paying you back over and over and over again. The obvious one, make sure you fixed a bug. Slightly less obvious, under the number 2, where I say catch regressions. Make sure that bug never comes back. No matter what happens, it doesn't come back. Or actually, that's strictly not true, right? A test suite can't prevent a bug from coming back. What it can do is it can tell you if it comes back. You can pinpoint problems in someone's installation. I have had that happen a lot, where somebody says, oh, this library doesn't work. I said, fine. When you run the test suite, what problem do you have? And it says, look, like 47 tests succeed and 1 test fails. Bing. Or 47 tests, all 48 tests fail for the exact same reason. That also tells you what's going on. Porting to a new platform, whether that be a new version of the operating system or a whole new operating system or a whole new set of hardware, the test can tell you, is your program healthy? Is your library healthy in this new place? In the last talk, there was a comment about legacy code. Legacy code is, the presenter said, it's code that you're afraid to change. Martin Feathers wrote a whole book, dealing with legacy code, and I'm not really sure why he wrote that entire book when the key point of the book was in the foreword. He said, legacy code is code without tests. I have a phrase that I've never heard anybody else actually use, but everybody I explain it to nods their head, says, oh yes, I've been there. I call it fear-based programming. You've been in a place where you look at some chunk of code and you say, this needs to be cleaned up. And somebody says, oh no, don't. You can't touch that. It might break something. That is where you don't have enough tests. Yes?
Uncle Bob uses that exact analogy in the TDD.
I'm sorry, I can't hear you.
Uncle Bob uses that analogy in the TDD videos.
Oh, he does? Rats, it wasn't original with me. Now I'm going to have to give him credit. That's fine. It's not a huge, massive insight, but I have certainly been in that place where you have, it's too scary to change.
Uncle Bob may have heard it from you.
Maybe, but I'm guessing not. Anyway, the other thing that TDD people tend to, what's a good way, emphasize, is you use your test suite to determine if your code is good enough to release. And I'm a big fan of that. Do you pass your tests? Is it good enough to release? Those two questions should be the same thing, right? If you have to do additional tests to see if something's good enough to release, well, you should be doing those all the time. I have a couple of, well, I don't have the examples in here, but I can tell you that when I have landed large new chunks of functionality into libc++ recently, they tend to be, counting lines of code, they tend to be about 90% tests. I landed an implementation of the upcoming STD span, which was 600 lines of code and 6,000 lines of tests. Maybe I'm just really verbose, but it gave me a lot of confidence in that code, and it shook out a lot of problems. Anyway, what is a good test suite? A good test suite is easy to run. It has instructions on how to run it, not just for you, but for your users. Okay? It's always green on your system. It should be always green. If it's not green, well, make it green. It's comprehensive. It covers all the stuff that you want to test. It gets run often, preferably on like every change. I mean, the TDD people are all about, every 3 minutes or something like that. Every time you add a few more lines of code. My test suite is a little more expensive than that to run, so it only gets run like on every check-in, but still, or before every check-in. But still, and easy to automate. You shouldn't have to do anything more than type in make test or something like that. It should also be, the other reason you want it easy to automate is because we live in a world where continuous integration systems are available and not very expensive, and hardware is cheap, and you can set up a dedicated machine just to run tests, and you don't want to go walking over there every 10 minutes and typing in make test. It should be automatable. Yes.
So do you think it's also the user's responsibility to run the unit tests?
Do I think it's the user's responsibility to run the unit tests? No, I don't. I think it's the developers, but users, you want to make it easy so that they can, if they choose to. And sometimes they can help you find bugs. They can find or installation problems or platforms you haven't considered, because there may be platforms you don't have access to. I got a bug report for libc++ last year that was about behavior on a MIPS 64 system, but the code was compiled for MIPS 32 and it was running in big endian mode. I don't have one of those. Right, always green. If you don't keep your tests running, keep your tests always green. If you don't keep them clean and passing, you'll stop paying attention, and pretty soon so will everybody else. It's like compiler warnings, right? If you're at 0 compiler warnings and 1 appears, it's easy to figure out what changed there and get it back to 0. If you're at 100 compiler warnings on every build and suddenly you're 101, will you ever notice? Yeah, a new test failure should be effectively a high priority interrupt. I talked about continuous integration a little bit. The project I work on, LLVM, we have volunteers running test bots. There's probably 40 of them, covering various architectures and various operating systems and various compilers. Same with Boost. Boost doesn't have quite so many because the Boost test suite is fairly heavy, but we still have 20 or 30 of them. And I have a little comment here that says, tests are a good place to let your OCD run rampant. Here's an example for Boost. This is both tests and documentation, example for both of them, okay? How do you run the Boost tests on your machine? It says 2 chunks of text here. This is supposed to be green, by the way. These green backgrounds here. Run 1 library's regression tests, run every library's regression tests. And you get this from the Boost documentation. So it's really nice that you can say, if you're on this new platform and you're not sure if your Boost library is installed correctly, run the tests and see. If the tests all pass, then it's probably installed correctly. Okay, any questions about docs or tests? Any more questions? Okay, tools. Let's talk about tools. This is not about dealing with users or anything. This is about making your code better. There's a whole pile of tools out there available for now. Compilers. We'll start with compilers. Compilers are really your first line of defense. What do? They can, well, if your code is ill-formed, they'll reject it. Okay, there you go. You give an error, it won't compile. But they also make suggestions about your programs, how your programs might be improved. Well, these fall under the general rubric of warnings. Static analyzers, we'll talk about, I have a couple slides about them. We have dynamic analyzers, We have code coverage tools. And we have fuzzers. How many people here are familiar with fuzzing and fuzzers? A few, okay. Maybe a quarter, probably a fifth. So I'll talk about those a bunch. Okay, compiler warnings. Different compilers will warn on different things. This is very much a non-portable area. This is something where compilers will, it's basically somebody had a problem and the compiler writer said, I'll help you out with this. Sometimes they point out problems in your code. Right here, right, you will get a warning from this. Why? Because this condition right here, val is less than int min, will never be true. Int min is defined for the minimum possible value for an int. We'll throw a compiler. It says, condition is always false. This one, this is legal code. This is legal code as well. This is legal code, but probably not what you want. It should be double equals. You should definitely look at your compile warnings with the goal of driving them down to 0, because then when new ones pop up, you just show up. Sometimes the compiler is just being dumb and being unhelpful. This is a line from my chunk of code that calls make unique unsigned char 0. And at least one popular compiler will throw a warning and will tell you that you are truncating this integer 0 to an unsigned character with a possible loss of data. Yeah, you're throwing away all those 0 bits, leaving fewer 0 bits behind. This is what I mean. Compilers sometimes just flat out wrong. Now, if this here was, say, 500, that warning would be correct. Because then you'd have, the 500 would get truncated to, what, 250, 244, or something like that. But in case of 0, it's just, you roll your eyes and say, dang. Anyway, Static analyzers. Static analyzers are complicated programs that basically symbolically execute your program. They read your source code and build a data structure, which is an execution profile of your source code without running it, and then walk this graph, this data structure, looking for potential problems. As such, these tend to be complicated programs. They tend to be expensive to run. Every compiler has a simple static analyzer inside of it. That's how they generate warnings. There are a bunch of commercial tools. Coverity, Fortify, and Clockwork are the most popular. Coverity has a free option for open source projects. Okay, each of these ones contain hundreds of little single-purpose checkers. That's what they call them. They're checkers that look for a particular kind of code or a particular code smell, if you like, and we'll tell you about them. I've used them. Sometimes they're really good. Sometimes they have a depressingly high false positive rate. I like Clang Tidy a lot because A, it's free, and B, it's easy to extend. Writing your own checkers for Clang Tidy is actually quite simple. And so you can find problems in your code. You can also, if there's an error you've seen a bunch, you can write a checker for yourself and say, oh, I don't want to ever do that again. Okay. Here's an example from Clang Tidy. Okay, here we have foo that takes an int and a double and a call to foo. It's perfectly legal code. Okay, the compiler will take this double and convert it to an int, and it'll take this int and convert it to a double, and it'll call foo. This is almost certainly not what the author meant. There's a Clang Tidy plugin. There's a Clang Tidy checker, I should say, that looks for function calls with two parameters where both parameters require an implicit cast. And when it finds those, it says, so what happens if I switch the order of the parameters? And then analyzes it again. And if that analysis realizes that neither of the parameters requires an implicit cast, then it will warn you on this. It doesn't actually change the order of the parameters. What it does is it will warn you, say, hey, this is legal code, but is that what you meant? And every time I've shown this to somebody, I've found something in somebody's code base that does this, that this particular checker goes off on. Every single time, they have said, oh no, that's not what I meant, and they fixed their code. This is not necessarily wrong code. It's perfectly syntactically legal. It's just probably not what the author meant. It's an example of a plugin. Okay, dynamic analyzers. Dynamic analyzers do their work while your program is running. They instrument your code or something, and then give you results at runtime. So what do we got, for example? The simplest one is assertions. Everybody's familiar with assert, right? You put it in your code, you say, I believe this condition is true right here. And if it's not, and you're running a debug build, you get a message on your console and your program dies. That's a very simple set of dynamic analysis, or example of dynamic analysis. Many programs, many libraries have what they call a debug mode, where you turn this on and you get a bunch of extra checking and reporting it at runtime. That's also an example of dynamic analysis. LLVM has popularized the idea of sanitizers, which are a set of checkers basically built into the compiler. The compiler will instrument your code, and then a custom runtime that will go through these checkers. How many people are familiar with address sanitizer or UBSAN? Good. Oh, okay. About 2/3. Then I'll give a quick overview. Address sanitizer was the first of the sanitizers. It's the most popular. Basically, what it does is it affects the layout of your variables in memory, both on global variables and the heap and the stack. It puts some space between them and puts some guard information around them so that if you write off the end of an array or before the start, or you corrupt your heap, it will stop your program, print out a stack trace, and tell you right here, you just wrote to entry 14 in this 12-element array. This is wonderful. I mean, how many people here have debugged heap corruption bugs? Yeah, I don't do that anymore. I hate those, and I don't do them anymore. There's a whole slew of sanitizers. There's address sanitizer, undefined behavior sanitizer. There's a thread sanitizer that looks for race conditions, and so on and so forth. Yes?
Can you integrate these dynamic analyzers into your CI pipeline, or do you have to run them kind of on the side?
So the question is, can you integrate your dynamic analyzers into your CI pipeline, or do you have to run them on the side? Yes, you can. I have, for libc++, I have test bots that run with address sanitizer, again, on every check-in. Gives me much more confidence in my memory.
Something that builds your program in special mode and executes
Yes.
uncertain conditions.
So the question is, do you have something that builds your program in a special mode and then runs it? Yes. The best way to run, that I have found to run this, to use the sanitizers is, you build your program with the sanitizers enabled. Now you have an executable. You don't actually ship this executable to any of your customers because it's got all this extra behavior that they probably don't want. And it's going to be, there's overhead here. It's going to be not as fast or larger than your production builds. And then you run your test suite. You build your test suite with address sanitizer enabled and run that. And this is great because A, you're leveraging the value of your test suite. Hopefully your test suite exercises everything in your library, and you go and find things. When I started using address sanitizer for libc++, it had like 10 failures, and 8 of them were traced to a single bug where in one place I was allocating 1 byte of, actually I was allocating a 0 byte heap block. And then when I needed to put stuff in it, I would resize it and then put it in. But there was one path through there where it would write 1 byte to this heap block and then resize it. But it started out as 0. And this would have been just impossible to find, especially since many modern memory managers round your allocations up to a multiple of 16. And so if you ask for 0 bytes, you get 16. If you ask for 17 bytes, you get 32. And so it wasn't actually overwriting anything, but it was technically wrong. And if I actually ever ported the library to a system that didn't have that kind of behavior in the system allocator, I was going to get heap corruption. So I had a presentation here at CPPCon in 2014 called Hardening Your Code. There's a lot more about the sanitizers and so on in that one, and that's available on YouTube. Okay, fuzzers. Fuzzers are basically a way of automating testing, not very targeted testing, but rather broad-based testing. When it comes down to it, what a fuzzer does is it generates random inputs and throws it at your program and says, what are you going to do with this? What are you going to do with this? This is kind of boring, right? You can spend something that takes, you can see something that takes tons of time and not really get anywhere on your program. Modern fuzzers are hooked up with code coverage systems, and so that as they're sending random inputs to your program, they're watching the code paths that get executed, and they're adjusting the inputs to find different code paths, different paths through your program. American Fuzzy Lop, or AFL for short, was one of the first of these, and it had an interesting demonstration. Basically, what it does is it generates a file, and then you launch your program with this file as input. And somebody tried this with a JPEG decoder. And over a space of about 3 days of just generating a file, tell the JPEG decoder to read the file, and then watching the code pass, AFL managed to generate a valid JPEG file, basically at random. This file looked like nothing anybody had ever seen in terms of structure of a JPEG file, but it was syntactically valid. And of course, the image inside it was just noise. But on doing so, it covered an awful lot of the decoding logic in the JPEG decoder. Clang has a fuzzing library built in. It's very nice. And also, the people at Google have set up a project called OSS Fuzz. If you have an open source library, you really want to look at OSS Fuzz. OSS Fuzz is, you can think of it as fuzzing as a service. Basically, you register your open source library with OSS Fuzz, and you write some glue code that says, what do you do with this random input? And then they will pull your code out of, say, GitHub, build it on their systems, and start sending random inputs via the mechanism that you have specified, and then send you bug reports. So I have done this for some of libc++. This is one of these background tasks that whenever I get some time or whenever I'm avoiding other work, I was like, what additional fuzzing tests can I add? So I'll give you an example. Sort, STD sort, right? What do you want to test for STD sort? You can give it random inputs. You can give it a random sequence of data, right? It basically sends me a random sequence of bytes, and so I say, okay, I have a random sequence of uint 8s. I say, okay, sort them. Now, does it crash? That's really useful information. But there's more information there that you can check. What are the postconditions of sort? The sequence is sorted. So you want to check that. You want to call sort and make sure the sequence is sorted. And there's a third one. Does the sequence contain the same elements as it did before it was sort? It's not really helpful if I give you a 5 and a 2 and a 1 and a 6 and you hand me back a 1, 2, 3, 4. It's certainly sorted. And so basically that's what the fuzzing test for std sort does, is it takes the input data, makes a copy of it, sorts the copy, and then checks to see that the sorted version is now sorted, and it contains the same entries as the unsorted one. Just as an aside, it's been running for a year. I haven't found any problems with STD sort, which is good, but it makes me more confident in my code. And the other thing is having this behind there makes me less afraid to go and change things in the sorting algorithm, because I have tests, deterministic tests that get run every time I change it, but I also have these random tests that run continuously. Okay. Address sanitizer and UBSAN work really well with fuzzing, because if you read off the end of an array or something, or if you have undefined behavior in your algorithms or in your code, the fuzzing is liable to trigger that. Last year at CPPCon, a year and a half ago at CPPCon, Kostya from Google gave a great presentation on the fuzzers. It was titled Fuzz or Lose. And actually, fuzzing is why browsers have gotten much more reliable in the last 5 years. HTML parsers, JavaScript interpreters, PDF renderers, these have all been fuzzed extensively. If you want to go go read release notes from old browsers like a couple years ago. There's a lists of bugs that are fixed, and they'll say, found using address sanitizer and American fuzzy lop or things like that. You just see them in the release notes. Anyway, questions? Yes?
I just comment, I've also used a thing called Clee, K-L-E-E, which is symbolic execution, which for really small bits of code is good for generating test cases.
Okay, the comment is that this gentleman here has used Clee, K-L-E-E, which is a symbolic execution engine to generate tests for batches of code. Yes.
Similar to Fuzzing.
What? Similar to fuzzing? Because it looks at it and generates a code coverage path? Cool. I have not used Clee before. I know of it, but I haven't used it. Okay. Let's talk about dealing with users. Okay. What do users do? They ask questions. They make comments. They file bug reports. They say, you know, your library would be so much better if it only did this. Make feature requests. Some of them offer contributions. Some people port them to new systems. You know, every now and then you run into somebody who's willing to put an arbitrarily large amount of effort into doing something to your library. This is great, right? We want to encourage all of these, okay? Happy users mean what? Mean more adoption of your library. People who are happy with your library will recommend other people. Say, hey, this library is really good. So what do you want to do? You want to make it easy for them to do this, okay? You want to make it easy for them to file bug reports. You want to make it easy for them to get in touch with you with comments or questions or things like that. How do you do this? In your documentation, you should have a link that says, you know, send feedback. GitHub makes it very easy to file bug reports if you're hosting on GitHub. If you're not, you know, you should have something set up so that people can get in touch with you. People offering contributions, you want to talk to them about copyright or ownership issues, but in general, it's really good to have that because you know, if somebody makes a contribution, even if it's a little one and it turns out well, they're liable to do it again. Anyway, so what do you do with these people? You say thank you. Really. Somebody who's using your library, even if they file a bug report, say thank you. They've gone to a bunch of effort to use your library. They care enough about it to track down what a problem is and to tell you about it because they want it fixed. They want to keep using your library. If you get a question, hopefully you intend to link to your documentation. If you don't have documentation that answers that question, consider writing it and then sending a link to the documentation. You know, and say to them, great question. I didn't have that in the documentation. It is now. Here's a link. Bugs should be fixed. Well, duh, bugs should be fixed. Or explained why it's not a bug. You know, sometimes bug reports are a result of misunderstanding, and in which case you should think about your documentation. Contributions, you got to think about them. You got to look at them, you think about it, discuss them with the contributor, decide if they're right, if they match what your vision for the library is. Sometimes you get a contribution that you just look at and you say, this is not a direction I want to go. Or maybe it's, I never thought of that. And then you can start a conversation as to why somebody thinks that's a good idea. And it may turn out we had that in the last session too. I think it was next door. Anyway, it may turn out that that's a great idea. It's just something you never would have considered yourself. Okay, I have a bug example here. libc++. I got a bug report that said basically the clear method for multimap was supposed to be no except, but it wasn't marked so. Okay, what should I do? What did I do? This is straight out of the TDD playbook, right? What did I do? Do we have a test for this? No, we don't have a test for this. Why don't we have a test for this? I don't know. Write a test. Watch it fail. Hey, okay, I wrote the test correctly. Add no except. Run the test again. Watch it pass. Hooray! Check in the new test and the fix. Straight out of the TDD playbook. Actually, it was a little more complicated than this. And that was because I took a step back and thought about the larger picture here. I said, multi-map. Is multi-map special here? Do we have a test for stud map is clear? Checking to see that that's no except. No, we don't. Do we have a test for stud sets clear? No, we don't. To see if it's no except. Do we have one for multi-set? No. How about the unordered containers? No. What about the sequence containers? What about vector? No, we have no test to see if that's no except. Do we have a test for forward list? No. Do we have a test for list? No. Oh my goodness, we have no tests at all for DEX clear method. Not even just see that it works correctly, let alone whether or not it's no except. Anyway, I ended up checking in 1 new test and 13 updated tests to fix this bug. As an aside, multi-map was the only one that was missing no except. All the other tests passed the first time. It was an oversight. Probably a copy-paste bug from somewhere else. But I ended up getting a new test and 13 updated tests from this bug report. And most of them had nothing to do with multi-map. So when you are tracking down a bug report, try not to have this laser-like focus. Step back, look around, say, is this a common class of bugs? Do we have tests for this? Yes?
So I have a question. I
Yeah.
also write C++ libraries.
Mhm.
I also try to test everything.
Mm-hmm.
And one problem I run into often is maybe similar to this, where I have classes that kind of share lots of similarities, like the containers, but they're not the same, and they're not even have the same base class or anything.
Right.
And then I end up writing like 90% of the tests are like the same. Like not all of them are the same, but most of them are the same.
Mhm.
For these 20 different classes, so it becomes really, really repetitive. And then it becomes really easy to have an oversight in the actual unit test.
Mm-hmm.
So how do you, what's the strategy of dealing with that?
Okay.
You run into this as well, and what do you do?
So summarizing the comment, summarizing the question is, if you have lots of related classes, like say all the containers in libc++, do you write a whole slew of tests duplicated for each one, changing only the normal bits? Or do you write some kind of comprehensive test that tests what a container is, and that you can customize for each container, and you have one set of tests for all of them? And the answer is, it depends. How's that for it? There are two sides to this. The first one is, I really like simple tests, okay? My goal for writing a test is, the test is correct by inspection. I do not wish to write tests to test my test cases, okay? I should be able to look at a test and say, yes, 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 okay. But as you say, you also end up with a lot of duplication. And it's easy for them to get out of sync, like this did, right? And so you can invest time and effort into building up, some kind of framework for doing similar tests. But then you have to worry about bugs in this framework. And so I don't think there is a, yes, this is better, or best, or this is best. It kind of depends on the situation. I inherited a bunch of these tests that are all separate, and we have talked about merging them into basically having a container set of tests in libc++. We haven't gone down that road yet. We'll probably try writing some and see how complicated they get, but don't know yet. Yes?
Some of the unit testing frameworks out there have methods whereby you can parameterize the test by time. I believe Google Test has.
Okay.
That sort of framework, so you can say, I want this test and I want you to run it on this list of times.
Okay. So the comment was, some of the test frameworks out there have the way of saying, I want to run this test on this collection of types. And yes, that would be good. I don't use any particular test framework for libc++ because all of the C++ frameworks depend on the standard library, and I'm testing the standard library. Yes?
Sometimes it happens that you want to test that something fails to compile. Maybe you are doing like some compile time checks and you want to check for that. How is it? Like I didn't find a simple way to actually do that. You really need to compile and check the compilation daily externally. Is there some ways that this is done in the C++?
Okay, so the comment was sometimes you want to have a test that fails to compile, and you want to be ensure that it fails to compile. And yes, you are correct. So in libc++, we have what we call failing tests, tests that are expected not to compile. If they compile successfully, that test is read. Unfortunately, it's really easy to write code that doesn't compile. And sometimes it's really easy to write code that doesn't compile for the wrong reason. I want to check if I can instantiate this class with this type. And the compiler says, oh, you forgot a semicolon here. And so we have a bit of automation around that actually will capture the output and look for particular error messages. Obviously, this is compiler specific, right? But while we're not restricted, while libc++ is not restricted to working with Clang, that's certainly what most people use it with. And so if you're running a test suite using Clang as a compiler, we check the diagnostics to make sure we get the right error. And certainly you can do that. You just capture the output and pipe it through some kind of tool that says, look for this string. And you could do it with a regex as well. But yeah, that's, when you're doing template meta programs, sometimes you want to ensure that, that everything fails. Yes?
One of the ways we handle that is using a technique from another talk of yours. We use the detection idiom. So, is this code valid?
Yes, that's another way to do it.
Static assert on.
So the comment here was, yes, I gave a talk a couple years ago at CPPCon about the detection idiom, or was that here? I can't remember.
It was on YouTube.
Yeah, it's on YouTube. On the detection idiom, which basically lets you say, is this chunk of code valid? And you could do that as well. You could say, is this chunk of code valid using void T as the mechanism in the C++ standard library? And then you can static assert on that. We don't do that both because our tests have to run back to C++03, but also because we want to make sure we get particular error message out of the compiler. But if you don't care about those, if you're willing to say C++14 or later, then yeah, void T is a really good way to go. Yes?
You mentioned you don't use any framework. Is there like a guiding principle or a short summary you can describe? Like, what's your principle of how you write tests without a framework?
Oh, sure. Tests are simple, short programs. You compile them, you run them, they exit with status 0. You're done. Inside there, we have basically we have a bunch of static asserts and a bunch of asserts. If the static asserts go off, the file doesn't compile correctly. If the asserts go off, it exits with a non-zero status. That's the gist of it. We have a few support classes that very, very, very hostile iterators, for example, for the algorithms, and a bunch of test allocators and things like that. But that's most of it. I would not recommend doing that right yourself if you don't have to. There are a lot of good testing frameworks out there. The position I am in with libc++, they're not available to me. Not because of legal reasons or financial reasons or anything like that, but for coupling reasons. Okay, anyway, one simple bug report, 13 tests. And I sent the guy who submitted this a nice little note saying, thank you, by the way, we didn't have tests for this, this, but they were all marked no accept. Okay, learn from your users. Here's an example. This was not really a bug report. We're going back to Howard's calendar library. Has a class in there, has various types, day, weekday, year, which are basically little tiny wrappers over an int, and a little bit of logic. In Howard's original library, these were not default constructible because it made no sense. What's the default constructed day? What does that mean anyway? 1, 0, 42? I don't know. It didn't make any sense to Howard, and so he didn't implement that. But it turned out that people wanted to do this. People wanted to declare a variable and immediately read it in from a file. And they did not wish to either specify an initial value or spend any time actually initializing this with something that was about to be overwritten. This is a reasonable use case. Same as this. Vector weekday, I want 12 weekdays, 12 default constructed weekdays. I'm about to read in 12 of these from some place, whether it's from a network or from a file or whatever. Anyway, so in the next version of Howard's library, these were all default constructible, and he just said, the value of a default constructible day is unspecified. It's something. You shouldn't really count on it. It's a valid day, but what? I don't know, 0, I think. But it doesn't matter. If you're going to default construct it, the expectation is you're going to set it to a reasonable value. But this is field experience, listening to your users. Find out how your users want to use your library or are using your library. Listen to them. Yeah, the users will use your library in ways you didn't ever think of. They're clever people. Some of them might be like really kind of twisted, but that's okay. All right, questions? Yes.
Interesting for these weekdays. What were they in fact initialized to?
What in the?
Were they not given a value or the value 0 or?
Unspecified. It didn't really, he very carefully didn't say, because he didn't really want to, the int inside, he really didn't even want to write to it. He just wanted to say, here's an int. Here's a thing that represents a weekday, and it has some number.
I think it would be interesting to catch use of that value as soon as possible. So
Yes, it would be nice to be able to catch that. It would be nice to be able to catch that where you could say, this is uninitialized, and when you try to use it.
and you can leave the memory uninitialized. There's a challenge that it would be 0. 0 is a quite useful value. So maybe I choose to set it to 3 or 7 or something.
Yeah, well, that's easy for you to do. Yes.
It's a design choice when you have such a thing.
These classes here have an OK method, which says, is this a valid day as well? So you can check that. But yeah, this was the motivating use case was, I'm about to overwrite it.
I couldn't use it.
Anyway. Let's talk about releases, release management. When your library is brand new, okay, when you're iterating quickly and you're building up functionality, you have a small user base, you kind of going to expect your users, the few of them that there are, to do what the abseil people say, live ahead. They go and pull a new version every day or so, because you're adding noticeable functionality on a very regular basis. But eventually, you'll start slowing down. And you want to start thinking about having actual releases. Because as people start depending on your library, they'll want to settle into a stable version and only change at regular times. Because the functionality that your library performs is important to them. It's now integrated into their business or something like that, into their processes. And so they'll want to change their infrastructure at times of their choosing, not at your choosing. You should think about having milestones or releases where these are designed to be stable for a while. Boost, for example, has regularly scheduled releases. They have 3 of them a year, every 4 months. In an amusing note, in an amusing coincidence, one of them is scheduled for today. It's not going to happen. It might be tomorrow. It will be very soon, but it's not going to be today. Anyway, you should definitely think about this. Consider having a schedule, okay? LLVM releases twice a year. These are big projects. If your project is not of the scale of these, you might just say, I'm going to have one in the spring, I'm going to have one in the fall. You don't have to commit to dates or anything like that. But you want to say, this is a stable piece of software, right? And you can go and grab this and use this. You don't want to say somebody's going to set this up on 6 different machines and they go pull, 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 pull and get 4 different versions. Yes?
What do you do in the case where somebody's dependent on one of your stable releases, but you've now advanced a couple of versions,
Yes.
and they find a serious bug? They don't want to upgrade because there's too much risk involved in upgrading to version 4 from version 3.
So the comment is, what happens if you, say, are doing releases and you do version 1, version 2, version 3, 4, 5, 6, and somebody who's on version 3 finds a serious bug? And they say, I don't want to upgrade to version 4 because, because that's risky, or because we've got a bunch of stuff built around this. That is one of the hard problems. I don't have a hard and fast answer for you. You're the one providing support. You get to decide how that works. You certainly want to investigate the bug and make sure it's fixed in your current release. Absolutely. But it's up to you to decide if you're going to go back and backport bug fixes. When I was at Qualcomm, we were doing firmware for various phone manufacturers, and they would frequently come to us and say, I need a new version of the software for this phone, which is exactly like that you shipped me 18 months ago with these 2 bug fixes. And it was important to them because if it had just those 2 bug fixes, they didn't have to have it recertified, and it saved them a bunch of money. Needless to say, Qualcomm charged people a lot of money for that, because it's a lot of work. You, as the library author, have to decide what to do about that. You could just say, no, we're not going to do that. In general, what Boost does is say, no, we go forward. The new version has that.
Do you effectively advertise? Is it a good idea to advertise that? Say, look, this is our strategy.
Yeah. You can say this. You can you put it in your documentation. Say, in general, this is what we don't go backporting bug fixes to old releases because they're supposed to be stable. Or you can say, my consulting rates are, or whatever. There's a whole slew of possible answers. What?
It's open source.
It's open source. You can say it's open source. Here's this. You have the source. I would suggest you do that right here, and then they can carry their own specialized version for a while. Lots of ways to go there. Other questions? I can't see any hands back there. I don't think anybody's got their hand up, but you people in the back right, I apologize if I'm ignoring you. Anyway, consider having a schedule. You don't have to. Again, it depends on your user base, right? Okay, what goes into a release? An announcement. You need to tell people, otherwise how are they going to find out? Some release notes. You know what? Write release notes. It is so easy to be better than most release notes. Changed in this version, stuff. I really see those. Or actually, I don't see stuff. What I see is bug fixes. Various bug fixes. I have seen release notes that's the complete release notes. Various bug fixes. Well, thanks for nothing. And in the announcement, you should have a method of obtaining the release. Where do I go to get it? Okay, release notes. Like I said, release notes are such a low bar these days. It's easy to be better than most. New features since the last release. Problems fixed. changes that affect users. If you've changed the calling convention, if you've added a parameter to this function here, say, I've added a parameter to this function here, you need to get the old behavior, you put comma false at the end, or even better, you have a named constant or something like that. I'll talk about changes that affect users in the next section. News about the project. If you have future plans, things that you think you're going to do, it's not a bad idea to talk about them here. This is what's coming up. I'm hoping to do this in the next 3 months, or something like that. You might get some people really interested. You might get some people who offer to help. Okay. Last major section, managing change. You like this? Two different ways of saying, as your user base grows, or as your understanding gets better of what you're trying to do, you'll find places where your library can get better. As in, you look at the code and said, oh, I can't believe I wrote it that way. Really? What was I thinking? Or you learn a new technique that will make your library much more performant, use much less memory, much faster, whatever. Somebody might suggest stuff for you. That's fine too. Right? Making these kind of changes, making these kind of changes is a tricky process. That's not true. Making these kind of changes is not really a tricky process. You just sit down and write code. Helping your users through these changes are a tricky process. Because it's both changes to the code of the library and the people who use it. If it's all internal, go nuts. Internal only changes don't affect your users, so not a problem. Okay, so when you make a change that affects your users, you want to consider both the costs and the benefits. The costs the benefits are usually very clear to you because you're the one who thought it up, and you say, hey, yeah, I can use 1/4 as much memory, or something like that, or I can speed something up by a factor of 2, or whatever. Some of the costs are borne by you as the author. Some of the costs are borne by your users. Those ones are not really clear to you. Your users will have to change. When you have 5 users, that's easy, right? You just call them and say, hey, guys, got to change this. When you have 50, it's a little harder. When you have 5,000, it's even harder. And you run into what you were saying, where people start lagging behind and staying on old releases. If you have 5 million, oh boy. I wrote a blog post a couple of years ago about this, about something in Boost.Algorithm, where I went back and forth on this. It was actually a fairly minor change. It was changing the return type of one of the algorithms. The blog post is titled, Sometimes You Get Things Wrong. And I went through a bunch of options, and I ended up going ahead and just making the change because none of the options were actually better than that. But I did explore a few. If you do this, how can you make it easier on your users? First one's obvious. Don't make a change if it's not going to benefit you and your users. If the benefit is compelling, people will step up and make the changes. Documentation. Is anybody seeing a theme here? Documentation. Tell people you're doing what you've done and why you did it. You can possibly provide both the old and new versions in parallel for a while and tell people this one's going away in 6 months. Give them time to make the changeover. You can provide example conversions, sample code that says this is how you switch from old to new. You could do automated code conversion tools. Google's Abseil library has promised to provide tooling to update every time they change an interface. Now, if you're a one-person part-time library guy, that's probably more work than you want to do. If you have 5 users, that's almost certainly more work than you want to do. If you have 5 million, maybe this is a good way to invest your time. I don't know. None of these are requirements, they are suggestions, especially this last one. But documentation is key here. Otherwise, you'll just start getting bug reports. Hey, my code doesn't compile anymore. And then you'll have to deal with those one at a time. Much better you write documentation ahead of time and give people a heads up, because then hopefully they will have seen it before it happens to them. Okay. Conclusions. Good documentation. Attracts new users, answers questions that people have without you having to do anything. This is, reducing your workload and making happy users. Tests. I mean, go nuts on your tests. Keep your code quality high. Make it easy for other people to run your tests. Excuse me. There's a lot of tools out there: analyzers, fuzzers, compiler warnings, and so on. Continuous integration systems, code coverage tools that you can help improve your code, keep your code quality high. Listen to users, treat them nicely. They're your friends. They want you to think well of them. You want to think well of them. They're using your code. They tell other people about your code. They tell other people that you were a jerk on IRC when they tried to ask you a question. That kind of thing goes around the world very, very quickly. Take field experience into account. If you get feedback from your users, hey, your library would be much better if it worked like this, listen to them. Decide if you want to do it. Don't reject stuff out of hand. Sometimes you're going to say no, but at least think about it. And tell them what you've done. Okay? Tell them what you've done. Sometimes even tell them why you did it so that they will understand. And when you're making changes that will affect the users, tell them about it. Think about how that will affect the users and tell them that the changes are coming. And that's the end of my slides. Thank you very much. Okay, here is a whole set of links about things I've talked about. The first one is about my employer. The rest of them are some of the blog posts and the talks I mentioned. Any questions? Yes?
Just on the testing one there, I find often you have to change your code a wee bit to make it testable. Maybe swap out some bits. And I had a sort of frank discussion with my boss, and he said, well, if you do that in your library, it makes it look like you can swap in other bits there. You've only put them in for your test cases. And he's saying, take that out, because that's not how the library's going to work. You're never going to swap that in real life. How do you manage that?
So the comment was, sometimes when you have to design stuff for testing, you provide mocks, or basically you're providing customization points for your library for the purposes of testing. And the problem is that people might see these as customization points and try to provide their own chunks of code to fit into those hooks. And you want to say, no, this is, you want to ensure that people don't do that. Basically, that you don't support that kind of stuff. And I don't know how to prevent it, other than, again, with documentation, and say, this is not a customization point. These are testing facilities, and we don't support people plugging stuff in here. Somebody might do it anyway, but then you can say, no, this is not what this is for. Sorry, you'll have to find another way. But yes, I understand that kind of thing, that kind of concern. But on the other hand, is having that and tests is, at least in my experience, been better than not having that customization point and no tests. But then again, I really like tests, so. I mean, the libc++ has what I consider a good start for the test suite. It has like 5,700 tests. And they take, on this laptop, they take about 20 minutes to run. On a big 24 core machine that I have at home, they take about 60 seconds to run, which is much better. Yes?
The way we handle that sort of situation is we hide it behind the public API. So the public API is a very thin forwarder to the function where you can mock and you test that function.
Okay, so the comment is that in his library, they have a public API, which is basically a very thin layer over the internal API, and all the mocking stuff is in the internal API. So it's not, I mean, if it's open source, it's still going to be visible, but you say, in your documentation, you say, this is the public API. This stuff here is private and you don't use it. The convention in Boost is anything inside a namespace named detail is not public and subject to change on every release.
That's exactly the same as us. We do exactly the same thing. We stole from Boost.
Yeah. You can certainly do that. You can have a convention because, you know, if it's open source, everybody can read it. But you can just say, you know, stuff in here, we make no promises on stability at all. Anybody else? Yes?
Do you have any ballpark figures for the division in number of lines of code and effort between real code and test code?
Any ballpark numbers between, you know, production code and test code? The only ballpark numbers I have is for recent chunks of functionality that I have checked in, and they tend to be about 9 or 10 to 1. 10 lines of test code per line of production code. Now, saying that, I have to tell you that I work in a very specialized environment. I have a written spec. It's 1,000 pages long, okay? And the tests come directly out of the written spec, okay? It says, this call takes these parameters, does this, these preconditions, throws these exceptions, right? And there are tests for each one of those. I do not know how common that is out in industry these days to have actually a stable written spec. But if you do, if you're lucky enough to, you know what your tests have to do. It just says so right there. And then you can, and that's a good start. Then you can start doing stress testing and, you know, trying very odd inputs. But your basic functionality test is spelled out in your spec if you have one. Lots of places don't. Before I did standard library stuff, I don't think I ever worked in a company that had a written spec that was not changing every day. Other questions? All right, thank you very much.